Hi everybody, welcome to another video in Math 1332, Section 1.2, Estimation, Graphs, and Mathematical Models. So, first part of this section we study about estimation, so that includes routing and estimation. So, before we go to rounding, we just need to note the number in decimal. So where the decimal point is, on the left is one place, the tens, the hundreds. On the right, the tenth, the hundred, the thousand, and then so on. So that focus on the decimal point. Right. The rule of rounding. So we look at the digit on the right of the digit where the rounding is to occur. If it is more than 5 or 5, we round that up to the next one, the next digit. If it is 5 or below, we just don't need to round up, we just keep that digit and everything on the right go to 0. So let's see. Here are some examples. We have 147.38, and now we round that to the nearest $10. So when rounding to the 10, meaning this is the 10 place, and that's what we round into. That's what we round. Right, and then we look on the one on the right of it. That will be a 7, right? If it is more than 5 or higher, we increase the digit that we're rounding. We go from 4 to 5, and then everything on the right we change to 0. So that's how we round that. On the question, they will tell you where you round the answer to. Right, so we say it. Yeah. So approximately we round to that. Sorry, the decimal. Right. Next, we're going to round this number into the nearest hundredth of an inch. The hundredth of an inch. Okay, the 100 place is the 1, 2 places after the decimal point. And we're going to round to that, and the one on the right is bigger than 5, so we're going to round that up, and so this we have 0.1 round to 2, and the other we're going to replace 0 into that. However, we read on this 0 after the decimal point, so this we just say 0.12. That will be enough. We don't have to write the zeros. That's that. Next is $1 million, a lot of money. So that is equal to 0.23749 of the amount of federal government spending in 2015 in just 1 hour. Right. So round that to the nearest thousand. Nearest thousand, so be the 10th, 100th, 1,000. So we're going to round to that. And we look at the digit on the right of it is 4. Alright, so it's less than 5. So we just replace all of that with 0. So we're going to have 0.23 and then 7. So we do not need to increase that digit, but we replace everything after that digit to 0. And once again, if it is after a decimal point, the trailing 0, we don't need to write those. So that's what we get. Right, so we can say that number approximately equal to that. Right, so that's what we do, really. Next, the estimation. Usually when we do the estimation involving calculation, we try to make things simple, so we can calculate easier. And then so in that case we round the number to the convenient number that we can calculate. Usually do this with this day and age, when we have a cell phone, that so every time we need to calculate we just use the exact number. But estimation is the good skill to have. It just gives you a better feeling of how the numbers, how big the numbers are. Right, so here are some examples. The owner of apartment complex needs to buy 6 refrigerator for the new building. She chooses a model that costs that much. Estimate the total cost. Assume in this case that no tax because it's not mentioned. Right. So estimate the total cost and decide if your answer is overestimate. Right. So we have 6, and each of them costs this much. So we have 6 times that. Now, it's just an estimate. We can just round this to 580, or better yet, if we just want to estimate something with a quick number, so we get the idea of how much the result will be. I'm just round this to 6 times $600. So I round that to $600 because it's very easier to calculate. On the homework, it will tell you where we want the answer rounding to. Right, so $3,600. So we get a quick number rather than type everything and get the exact number. So in this case, we get a number, just an estimate. Right, now, is this overestimate? And the answer is yes, because that number will round up to a bigger number. We know the result is going to be bigger. The result is actually going to be smaller than this number. This number is going to be the high end, a little more than the actual number, because we know for sure that is overestimate because we choose a number that is bigger to estimate, therefore overestimate. Right. Next, consider the new cell phone plan where you have to pay up $179 upfront, but monthly charge $39.99, include all of those plans. Estimate the cost of the phone for 1 year if there are no additional charges. So we start with $179. And then we have $39.99 for each month. So there for the whole year. So that means 12 months. Right, so I'll get a quick approximation. We can round this to 200, or we can round that to 180. But since this is addition, 180 would be enough to calculate. And this I will go with 40. Right, $39.99 round to 40. That would be perfect. Times 12. Now it's 180. 4 times 40 times 120 is 480. And estimate that will be equal to 660. But like I said, right now we cannot go anywhere without a cell phone, or we just find the exact values of 179 plus 39.99. Right, so we have that much. So you see, we did not overestimate by much. But the point of the idea of estimation is just we can get the number very quick. Actually, ideally without using a calculator. So round to a number is easy to calculate. Right. Another point, while rounding up or down to intentionally get either overestimate or underestimate. For calculation, addition or multiplication, sometimes we round one up and one down. So in that case, we have something in the middle. Right. One thing though, usually in terms of money, sometimes if we want to purchase something, it is better to overestimate because it is sometimes if we have a little more money, that is better than we don't have enough to buy some certain things. So overestimate, in that sense, is a little bit better. But what it says here is sometimes we can round one up and then one down. In that case, it's easy to multiply, mostly multiply, not adding. So here we say those Spional family plans to remodel the living room. They will need 21 square yards of carpet at that price. And they also need 26 linear feet of ground molding installed. They want to estimate 1,000. So estimate the cost per foot of ground molding that they can afford. All right, so we start with 21 square yards at $23 each. And then we plus some dollar amount of 26 linear feet that have to add up to $1,000. Now we're going to estimate that question mark there. Right, first, to get this, we just round to numbers. Of course, we can round this to 20, we can round this to 30, but that 30 will be too much. So how about just 21, we'll round down, and 23 will round up. So in that case, 20 times 25, that's 500. It's easy to calculate, right? So that is 500. So 500 plus something is equal to 1,000. So that means this something is 500. And then we just divide by 26. So the cost is estimated to be 500 divided by 26. If we want to do the number easier, we round the 26 down to 25. And we have about 20. So that's what we have. So the answer is about 20. Like I said, it's just an estimation. So $20 a foot. Right. Next we'll study about graphs. So there are different type of graph. The bar graph, something like this, where we have the column represent a number. The bigger the column, the taller the column, the higher the number is. Then we also have the pie chart. Pie chart usually to go with percents. The bigger the sector, the bigger the percentage. And then we also have time series on the line graph, something like this. Right, so let's look at some example. The graph shows the number of suicide every 100,000 people, broke down into male and female. Sorry, color kind of difficult to see, but let's say it. I just so that will be male and female. Right. We look at the graph and say, how confident are you? Okay, what is that? use the graph to find out how many suicides were male in 100,000 between 15 and 24, and estimate the largest discrepancy between male and female. Right. So first, if we want to find a number between 15 and 24, so that we have this. So that is about between 20 and 15, so let's say 17 and a half. So the first question is how many in the 14 and 25 range male? So the answer to that is 17 and a half. Just an estimate. Also estimate the largest discrepancy between male and female. So if we look at this, look like over this region, that is the highest difference. So one of them is about 31, the other one is about 5. So if we take 31 minus 5, so that's about 26. So that is the highest difference of any age group, right? So usually this type of problem, we just look at the graph and find the information, the data from the graph. So pretty much that. And the second part of the question is estimate the largest discrepancy between male and female. That would be this. How confident are you in those estimates? So that's pretty good estimate. Because the number, we get the number very clear from the graph. Right. Next we have a pie chart. That will be the number of fatal occupational injuries. And this is what we have. The total is 4585. How many of those result from axonal and violent acts? So if we look at this, we have 17%. The answer is 17%. But since we have the total number, we have 4,585 times 17%. Right. Of course, if we have the calculator, that would be easy. But if we don't, how do we estimate this? Well, we round that to something easy to calculate. So I can round this to a bigger number or a smaller number and round that to a bigger number. But let's say 17%, you can round that to 20%, or you can round that to 15%. So it depends. So I just do two different ways here. So first, let's say if I round that number up to 6,000, 5,000, sorry. Yeah, let's round that to 5,000. The question asks us to estimate. So round that to 5,000. So if we want round one up, the other will round down. That is percent. But actually, percent meaning that 5,000 multiply 0.15. 5 times 15 is 75. Similar 500, and the decimal place will be 2. Sorry, 75. 5 times 15 is 75, but there will be 3 zeros, and then the decimal point will be 2 decimal places, so 750. So that is if we round that way. If we don't want to do that, we round this down to 4,000 and we round that to 20%. Or if we round to 4,000 times that to 20%. or we can say it 4,000 times 0.2. Now 2 times 4 is 8, and then 3 0, but there one decimal place, so about 800. So 750, 800. Right, if we have the calculator, 4585 times 17%. Right, so our estimate of 750 or 800. Oh, that's good. Right, so in calculation, in multiply, something we write one up, one down. So we had it's easier to calculation. Easier to find the calculation. Of course, in that case, we really don't know if it is an overestimate or underestimate when we round one up, one down. If we round both them up, we know that overestimate, but this we don't. But the number will get close to the actual number. We try to estimate. Right. Good. Next, the graph below illustrates the number of Americans that were living in poverty. All right, so from 1990 to 2015. Now, there are two graphs. Give you the same data. However, if we look at this data, we say, right, in terms of number of people in millions, well, that not increase by much. It is increasing, yes, but not by much. And this is number of millions of people. Right. So in a sense, it's not really all bad, even though we said the number of people living in poverty increased. But think about this, from 1990 and then to 2015, well, actually there will be more people. Therefore, there will be more people living in poverty. It's just like if you claim that you have the most vote ever, well, that makes sense because we have more people more than in the past. Then the number of votes certainly will be more than the past as well. Right. However, of course, if it is decreasing now, that is significant because the number of people tend to increase. So anyway, so there are two type of graph though. They give you the same data, but this one will give you a better idea because this will tell us the actual scale between the numbers. Even though we said between this number and that number, they're not really double, or this is more like if you say this much and that much, you have a sense that this is a lot more than actually that, many times higher than that. Right. So if we want to look at the graph to tell the scale of how many of this compared to what number we need to multiply by this to get to the next one, this will be better. This will actually help us to find the actual numbers. Easy to find the number because data is easy, but we never say this one is have let's say 5 times than that. It's not going to be the case. We're not going to tell the ratio of the numbers where we don't have the zero in that case, right? So this we can say the difference. The numbers are easy to see, but we cannot see the ratio, the relation between the numbers as good as this, right? So the question here is approximate the number of Americans living in poverty in 2015. So on this graph is kind of difficult to see. So we say this about between 40 and 45, so I said 43. Or this graph will be better. Right, actually 43 and a half. Or actually 43. So we say about 43, and the unit is millions. Now, I'll find the average rate at which the number of folks living in poverty changed from 1995 to 2000. So first, average from 1990 to 2020. 20. Oh wait, what do they want? 1995. 1995 is this data. So about 36 and 20, and then 2000 is 32. So from 1995 to 2000, that's 5 years, right? So in 5 years, it's decreased from 36 to 32, right? So we have 36 millions minus 30, I'm sorry, if we want the rate, we take the number in the future minus the number in the past. So we should take 32 in 2000 minus 36 in 1995. That gives us negative 4 millions. So we have to divide by 5 because that in 5 years that is was negative 0.8. So the unit in this case we said millions people a year. So from 1995 to 2000, the number of people living poverty decreased by 0.8 millions a year. Right? Look at this graph. For this graph is the average cost of tuition and fee at a public 4-year U.S. College. So in 2000, it's going to be that much, and in 2016 that will be that much. Estimate the yearly increase in tuition fees. So this is yearly from 2000 to 2016. That's 16 years. So first we write in 16 years it is increased by 1940 to that. The future number in the future minus the number from the past, or the final minus initial. In this case, I actually just use the calculator here. 94, 10 minus 33.49. So you have 6,061. Now if I divide this by 16, so you have about that much. So each year we have that divided by 16. So we have, I'm just going to say, we have 378.81. So each year it is increased by this much. Right. Write a mathematical model to estimate the average cost at the public 4-year college years after 2000. So we know that at 2000 the cost is $3,349, and for every years it is increased by this much. So it increased $378.81 for each year. So that is the model for it. So we start from this much, and each time it's increased. Each year it increased by this much. So let's say 10 years. So we need to increase that by 10 times. And 2000 should be 0 year. So it will be exactly that. So we said this is the model for the tuition and fee for X years after 2000. And with that, we finish section 1.2. Thank you for watching, and see you in another video in Math 1332.